Excuse me. Should we admit that person?
I'm not sure. I can't seem to get a hold of them.
Excuse me. I'm not sure if it's okay to ask for their name, just to make sure they're the registered.
Okay. All right. If anyone needs a name change, if your name on the screen isn't your actual name, you can just type it in the chat and Alyssa and I will change that for you. But let's just get started now. So, good morning, everyone, and welcome to today's live learning session of solar energy under our topic of engineering and sustainability. So just a brief introduction. My name is Anna, and I am an engineering outreach program instructor here. And I'm also a software and biomedical engineering student in my second year.
Awesome. My name is Alyssa. I'm an engineering outreach program instructor as well, and I'll be teaching alongside Anna today. I'm also a mechanical engineering student. I'm going into my fourth year, and I also go to Ontario Tech, which is the school that runs these programs.
So we're just going to quickly go over our code of conduct here. So just as a reminder, please join the Zoom session with your first and last name. And if you don't have your name, again, just type it in the chat and we will change it for you. Please keep your microphones and cameras off for your safety and privacy. You may keep your cameras on if you feel comfortable, but if you don't want to, that is perfectly fine. And also, our chat function should only be used to talk about our activity during today's session, just so we don't miss any comments or questions and people don't start spamming in the chat. And lastly, of course, please respect everyone in the virtual classroom as you would in a regular classroom. And if you need any guidance on how to use any of the Zoom features, on the bottom left, you have your mute and video buttons. And the chat bubble is, of course, for the chat. And we also have our reactions button. So if you click on the reactions button, you can either raise your hand or give a reaction to whatever's being said. And just as a disclaimer, all of our live at-home learning sessions are being recorded and live streamed so that other students can watch in on our session as well. And the focus is just going to be on our instructors and our presentation. So you're not required to turn on your camera or your audio, and you can just use the chat function. Now, this is going to be a bit of a review from what you guys have covered in the past weeks. But so who here remembers what STEM is all about? I know everything it's stood for is on the screen here, but who here remembers learning about STEM? You can just type a me or a yes in the chat or raise your hand. Awesome. Everyone's well-versed on engineering and STEM. That is great. So just as a quick overview, STEM stands for science, technology, engineering, and math. And engineering brings all of our STEM disciplines together. So it brings science together and gives us the understanding of the world around us through experiments. It uses technology as tools and machines that help us solve problems, and it uses numbers and shapes and patterns to understand the different things in our world. And when you put it all together, we're able to solve real-world issues by designing and building models. So again, this is just a review, but what is engineering? Now, our definition here is engineers invent, design, build, test, and analyze machines, systems, and structures to solve problems while considering cost, safety, and practicality. Now, this sentence seems extremely huge, and the reason why it's so detailed is because engineering is such a broad field, and there are many different types of engineering that are required to cover it. So, do you guys know any types of engineering? If you do, you can type it in the chat. There are a bunch of different types. So Tree says software engineering. Yes, absolutely. Software engineering is a very, very big field of engineering. Anushka says mechatronics. Yes, for sure. Mechatronics is super cool. Got more software engineering from Nathan and Jason. Mechanical. That's definitely a type of engineering. That's one of the oldest and most prominent fields. I can't see the names of the people with their hands raised. I think that's Nishi. Oh, never mind. And whoever has their hand raised right now, I can't see your name, sorry, but you can answer the question. Oh. Okay. Anushka, you want to be a mechatronic engineer? That's awesome. I also wanted to be a mechatronics engineer at one point, then I switched to software. It was up from before. Okay. And Nathan and Jason say electrical. Awesome. So you guys know so many things about different types of engineers. Now, I just have a couple examples of them on the screen right here. First, we have mechanical, aerospace, mechatronics, computer, civil, biomedical, chemical, and electrical. So these are just a couple of the different types of engineering, and they're all quite different, and they solve different engineering problems, which is why we need so many different fields. All right. Now, even though all of our engineering streams are very different, they all use the same process called the engineering design process, which I'm just going to quickly review with you guys one more time. So firstly, we need to be identifying the problem. Next, we want to gather what we know and brainstorm ideas that can help us solve our problem. And next, we want to take our best ideas and begin planning out our solution. Next, we want to be making our model. Yep, Nathan and Jason got it. We are building a model. And we want to build a model because we don't want to start off by building a life-size version of it. And Nathan and Jason guessed it again. Test and evaluate is our last stage. And even though it looks like our last stage, it really isn't our last stage, because during our test and evaluate stage, we can always think back and figure out what we could have changed, and we can sort of treat our engineering design process as a loop and go through it as many times as possible, repeating the cycle, absolutely, you guys all know it, until we have a solution that works the way we want to. All right, now to pass things on to Alyssa.
Okay, awesome. So you guys learned all about a brief introduction about engineering and what it is and the different types. And I'm really glad that you guys know a lot about it so far. But today we're going to look at our content. So we're going to do a little bit of a recap of what we learned in the last episode. So I believe you guys learned about hydropower. That was the topic of your last episode. And you learned about work and how that plays into what hydropower is. So we know that machines like the ones that you see on the screen, like the mechanical machine right there, do work to move water. So work is the amount of energy transferred by a force on an object. So in moving this water, this kinetic energy or energy of motion also produces mechanical power, which in turn does work. So, and we also learned about how hydro plants, they have three parts. There is a dam, there's reservoir, and there's an electrical plant. The reservoir keeps the water in, the dam makes sure the water doesn't go anywhere, and then the electrical plant does work in order to turn that water, move it to create mechanical energy. And then we can use that the mechanical energy to produce electricity. Speaking of electricity, we talked a little bit about electricity as well. And if you don't know what electricity is, I'll briefly go over it. So we're going to be talking about how it relates to our topic today, which is solar energy. So at a very, very microscopic level, electricity kind of deals with atoms. And do you guys know what atoms are? Have you heard of that term before? Yes, awesome. Cool. Can anyone tell me? Nice. Yes, matter. Exactly. So an atom, yes, we do, but no worries. I'll explain what an atom is if you've never seen one. And yes, exactly. You've probably never seen an atom before, like in real life. You've probably like never really seen one up close because they're very, very, very small. So atoms basically are like particles that make up, everything in life, from the things you see on your desk to like the things that, make up your body. Anything in the world is made up of matter, and those are made up of atoms. So if we look at a closer level, atoms are consisted of three particles. There's something called the neutron and the proton, which exist in the nucleus. And then there's also something called the electron, which revolves around the nucleus. So what's interesting about these particles is they all have different charges. So you can see that the proton is positive, the neutron is neutral, and the electrons are negative. What's really cool is that these electrons that revolve around the nucleus, a bunch of different atoms, if they come close to each other, these electrons can jump from orbit to orbit between different atoms. So they don't just stay between its own atom. They like to move around a lot. But the fact that they move around a lot, that creates the electricity. The movement from atom to atom of the electron, that is electricity. And you can kind of tell because electricity starts with elect or elector with the R, which is very similar to how electron starts. So now you know. If you're trying to remember which particle it is that electricity deals with, it is the electron because they start with the same couple of first letters. Okay, so we also want to talk about heat transfer. And heat transfer is a really, really important part in solar energy. Does anyone know why? Yep, thermal heat, exactly. So the sun creates a lot of thermal heat. If you ever stand underneath it, you'll know it's quite hot. And if you look at it, don't look at it too long. You don't want to burn your eyes. But you can feel, how hot it is. So this is one version of heat transfer that we go through daily. If you've ever stand under the sun, even if it's cold, dead of winter, you could probably see its effects if it's melting the snow. So there are three types that we want to talk about. The first one is convection. So convection is the movement of heat by actual motion of matter. So if we take our example of the pot with the boiling water, you can see that the water is, as it's boiling, it's moving the particles around. It's not just standing in one place. So that is convection. So as the particles are moving around, they're moving a lot faster. So then that creates the boiling sensation. Another example is conduction. So conduction is the transfer of heat or thermal energy by direct contact. Very similarly, as I explained with the sun, if you stand under the sun, you'll be able to feel it beating down on you. That is an example of conduction. Final definition is radiation, which is the type of transfer of energy by electromagnetic waves. This one is probably the most difficult one to notice, partially because the first two are much easier to notice in examples. But this one, if you go near a fireplace, you can see that it's looking hot. If you look like above the fireplace and you see the smoke, you can also see that if you look through it, it's not very clear what you can see through it. So that's an example of radiation. If you ever go camping this summer, check it out. Okay. So today we are here to talk about solar energy because this whole week of sessions or this whole season of sessions, we're going to be talking about different types of energy. Today, we're going to be talking about solar energy, and it can refer to something as simple as the energy gathered in your parked sealed car or your solar collector and converted into heat. If your car is really, really hot when you come into it during the summer, that's an example of solar energy working. It's also used to heat houses. So, if you have your window open and you keep your lights off, then maybe the sun will come in and heat up your house that way. What's really nice is it's a natural source of energy. So you don't need any electricity or any fuel to gain that heat in your house, which is cool. What's really interesting is that sunlight contain photons. Does anyone know what a photon is? Has anyone heard of that term before? And if you have, exactly, Nathan and Jason. You've heard of it, awesome. Sounds like most people know what it is. It is on the screen, but I'll briefly explain it for those of you who don't know. So photon is another type of particle, kind of like your neutron and your electron and your proton. That, it's very, very small that you can't see it, but does a lot of work in the field of science. So a photon is a particle that transmits light. So it's a light particle, which the sun has because we know that the sun it comes up and it gives us light for the day, right? So that's really interesting. We'll talk more about photons later. But the most important thing to know is that the solar energy, we use the sunlight to generate thermal energy, or the energy that heats up things like your car or your body when you're outside. Okay, so along with solar energy, you probably might associate solar energy with solar panels. Has anyone seen a solar panel before? Or does anyone have any in their home?
I saw some, and I have one in my home.
Awesome. That's so cool. Solar panels are really, really cool. They generate a lot of good renewable energy. And to have one in your home must be like really, really cool. So to convert solar energy into other forms of energy, such as, let's say, electricity, which is probably, if you have it in your home, you probably convert it to that so that you can use it around the house. We use solar panels. Solar panels are made up of a bunch of photovoltaic cells. That's a very long word, so I'll explain what that is. Photovoltaic cells, they absorb the photons produced by the sun. So here's where our photons come in. So again, photons are light particles that contain different amounts of energy depending on the wavelength. Because, depending on the color that comes through, if you know the spectrum of visible color, wavelengths are different depending on if it's like a red wavelength or a purple wavelength or ultraviolet. So that's very interesting. So these photons are either absorbed, reflected, or pass through these photovoltaic cells. And they typically generate direct current, but if we're putting it into commercial use, which is essentially what that means is if we're gonna use it for a lot more electronics and a lot more uses than just maybe a small battery that we're going to power with our solar energy, we need to change it into alternating current so that we can use it more widely. Okay, cool. So if you've seen solar panels, that's great. There's a lot of places, if you go outside of Durham, if you go outside of Toronto, more so in the countryside, you'll see a lot of these solar farms. This one is in Sarnia, which is also in Ontario, but it is the largest solar farm in Canada. I've never been there, but always wanted to go because I want to see how massive it is. But it's quite cool to see, all of these photovoltaic cells working together to create energy for cities and towns like yours and mine. So you'll see on the right hand of the screen that there's a 4-step process on how these solar panels work. Quickly, I'll go over it. So the energy of the sun will be converted into electrical energy from these solar panels. And that is their job. That is exactly what they do. And then the electricity that is converted from the sun through the cells will be sent through a transmission system, and then they will be delivered through communities who need it. So you may use some energy that might have been converted from solar energy not too long ago. So something interesting to research or look up when you're not busy is how much of my energy that my house runs through or my house uses solar energy. Because that must be really, really interesting to know. I'm curious to know. I'm not sure what it is, but another cool example is the National Stadium in Taiwan. So this is really cool. You can see it's kind of in the shape of like a dragon. And you can see like the photovoltaic cells, the solar panels like spread across like the whole roof of it. What's cool is that it could seat about 55,000 people, and many football matches take there. That's the purpose of the stadium. And again, like I said, the solar panels that are placed all across it generate most, if not all, of its power for its operation, as well as extra. So if the power goes out, then they'll have energy that they can use. Another great example is the ISS, or the International Space Station. They use many solar panels to do many things. They use to communicate with engineers on NASA back on Earth. Solar panels, on satellites are really, really important. If you know about your internet, or even just like calling someone, if you want to call someone from another side of the world, those really help out in that sense. And a really cool one that I never knew about before was this Panda power plant in China. So like I was talking about earlier, there's this farm in Sarnia that has a bunch of solar panels. This one in China, they have them shaped and placed around so that they make the shape of a panda. So if you fly across the power plant, you can see they look like pandas. It's really, really cool. And the amount of space they take is about 100 hectares of land, which is a lot of land. But it means that they produce a lot of power, which is really, really cool. So if you ever have a chance to visit China or Taiwan or go to space, I would highly recommend asking about their solar panels. It's really, really cool. Okay, so there are pros and cons to solar energy. I have some on the screen here, but does anyone know of any? Let's go with the pros first. What are some pros about solar energy? Why would we use solar energy? What's so good about solar energy? What do you guys think? It's clean, for sure. It's definitely clean and renewable. Yep, exactly, it's renewable. Yes, Kareem, I think you have your hand up.
Yeah, and they are not harmful, and they can be used any moment, and they're reusable, and then lower electricity.
Nice, yes. Exactly. So, awesome. So yeah, there are many pros to it, and you guys named a bunch of them. It is very renewable. We won't run out of the source because it's always going to be sunny, which is great. Even on the cloudy days, the sun's still hiding behind the clouds. So the sun probably won't disintegrate or not exist for a while, which is great. I don't know if someone said if it is not harmful, it doesn't produce harmful byproducts. For example, if we take something like gasoline, the amount of greenhouse gases it creates, that's a harmful byproduct. So the sun doesn't do that, which is quite nice. Another cool thing is that it can be used for 30 to 40 years, which is really great because we can keep on using this resource over and over and over without having it be depleted, but also at the same time, it'll be used for other generations of people as well. And finally, I think Kareem answered this. It lowers the electricity bill. So if you live in a house that you need to pay the electricity bill for, it is a lot less expensive if you have solar panels in your house because they generate extra electricity that you don't have to pay for with your electricity bill. Now let's talk about the cons. I think some people were talking about it depends on the weather. That's definitely one of them. One of the very, very important ones to discuss about the cons of solar energy. Does anyone know any other cons about solar energy? Why wouldn't we use solar energy? Yes, Prapti. Do you have an answer?
Because it costs a lot.
Yeah, for sure. It costs quite a bit to install these solar panels into your house or even just making farms, because they're a very, very expensive technology for sure. Yeah, and buying the area is quite expensive too. You need a big area to have enough solar panels in order to make enough energy to per se, provide energy to a home or provide energy to a city or a town, right? Yeah, so money is definitely something we have to think about, and that applies to every engineering problem that we go through, right? We don't have all the money in the world, so we have to think of what is the best option for our problems that is cost friendly as well. So one more, I think, I don't know if people mentioned or not, is the one at the bottom right, is that it needs to be designed to work better and to be more eco-friendly. So as of right now, yes, Kareem.
Like, what? Are we gonna do something after we're done doing this?
Yes, of course, we will.
Craft?
Yes, we will. We have a great activity for you that we'll learn how to use solar energy in this activity, and you'll get to use it in practical use, which is really cool. I just want to talk about a little bit about solar energy really quickly so that you get like the gist and understanding of it before you go into the activity, just so you know what you're doing.
Okay, one question for safety. Does it involve wires?
No, it doesn't. So you don't need to worry. You will be safe. This is student friendly. So you don't have to worry. You'll have a lot of fun, I'm sure. But thank you for asking. I'm glad you asked that question. But awesome. It sounds like people know, all about solar energy and how great it is. So we'll move on to one more thing. I want to talk about solar ovens because this is exactly what our activity is going to be today. So some of the energy produced by the sun reflects off of the atmosphere, as you can see in the picture here. Some is absorbed and some penetrates through, kind of similar to how the electrons do that with the photovoltaic cells, right? So this is called the greenhouse effect. And the effect is essentially the energy or the sun's energy that passes through the atmosphere and can't escape, that's absorbed by the Earth's surface and the molecules heat up the matter within it. For example, I had the example of your car. When you walk into your car on a hot day, it must be really, really hot and it feels like a sauna. Another example is if you stay in front of the sun, part of those particles that are making you hot are the particles and the energy that's absorbed by the atmosphere and the ones that can't escape the atmosphere. So the electromagnetic rays that the sun emits has lots of energy, and that causes the molecules to move faster and faster, and it generates a lot of heat. That's why you feel so hot when you go outside on a sunny day. Speaking of that, we are going to be using that concept of the electrons moving fast and creating heat to create a solar oven. We're going to harness this energy in that solar oven, and hopefully, I don't know if we could do this as of right now in the session, but hopefully we will be able to heat up some marshmallows or heat up some s'mores with your solar oven. So I will pass it back to Anna to talk about the activity for today.
Thank you, Alyssa, and thanks for telling us all about solar energy and how solar panels work. So first, in our engineering design process, of course, we want to identify the problem. So our mission is to help the hungry Lego astronauts set up a lunar base, so on the moon, by using solar power to create some delicious s'mores. So on the right over here, we've got our little Lego man, and he's living on the moon, and he wants to enjoy a toasted, nice s'more while he's there. So next, we need to be brainstorming some ideas. So this is when we can start coming up with some supplies that we might need in order to create our solar oven. So first, we're going to be needing some tin foil, which is going to help us direct the sun rays into the oven. We need some plastic wrap, which is going to provide insulation and sort of prevent the heat from escaping. And we need black paper that's going to act as a heat sink. So black paper absorbs all different colors of light and all different colors of radiation. So that means that it's going to absorb the most amount of our thermal energy. And lastly, we can use some crayons that are going to act as our s'mores to melt if you want to test it out in the sun later on, or you can get some marshmallows or some bread that you can toast. So right now, I'll just give you some time to gather these materials that are on the screen here. And I'm going to set up my materials myself because I'm going to be building one with you guys. So once everyone has their materials, just type yes in the chat or give me a thumbs up reaction so I know we're ready to get started. All right, a couple of us are ready. Awesome. Okay, I'll just wait for a couple more. Just type yes in the chat once you have your materials and you can get started. And if you don't have some of the materials, you can just let me know and we can think of some alternatives. All right, I see some pizza boxes. Awesome. Nathan and Jason, yes, we're making sort of like an outdoor mini grill. It's going to be kind of like an oven. All right, I think most of us are ready now, so I'm going to move on to the next slide. Oh, someone's not ready?
I'm not ready.
Not ready? Okay. Are you missing a couple of materials?
Yes.
Okay, we'll give you a minute.
Okay. And I don't know if I have too many wooden sticks.
That's okay. You only need 2 of them, I think.
2?
2 should be enough.
Okay, then that's good. One. And we need glue?
Yes, we need glue and we need some tape.
I don't think I have any glue.
That should be fine. Just tape should be okay.
Okay.
Just grab my stick.
Do I need crayons?
You don't need crayons. They're just for testing out if your solar oven works later on. You can test it out with anything.
Oh, for the crayons to melt?
Yeah, absolutely.
I think I tried that before and I don't think that would work well.
That's okay.
So messy. And
yeah,
if you
it is pretty messy.
do them over and over again, you're going to have to put plastic wrap for the food and so then you can just take it out and then throw it out.
Yeah, for sure. All right. Now I think we're all good to get going now, so.
Wait, can I see if I still have all of the stuff I need?
Yeah, sure. I'll just leave slide on for a couple more seconds and then we'll move on. Okay, Kareem?
Okay. Paper, ruler, and pencils. And tin of oil and tape. Okay. Wooden.
Is there anything we can use that's not black paper?
Pardon?
Can we just use regular paper? Instead of black paper?
We need to use black paper to act as our heat sink because black absorbs the most amount of heat. Today I don't, my black paper got ruined when I left a window open. So I just colored some white sheets of paper black just to represent the black paper, but fully black paper is preferred. Okay. Just wait a couple more seconds and then we will get going. I'm excited to make my oven and make my s'mores.
You can't use a color that is almost as dark as black?
Yeah, any dark color should work. If you have like a dark blue, dark purple, dark brown, anything.
How many do we need?
We need probably about 2 sheets of paper. We just need to make sure that we fill a good amount of our pizza box with it. So if you can fill most of your pizza box with it, that would be great.
Because I have two black pieces of paper and the other ones are hard to get out.
The 2 pieces are perfectly fine. 2 is good enough.
Okay.
All right. Dark shirt is gonna burn. Yeah, when you're out in the sun and you wear a dark shirt, it gets really hot, and that's because dark colors absorb all the different colors of light, and that's why it gets so warm. Great observation. The shirt, if you have an old shirt that you don't want to burn, then you could use that one. All right. I think we can move on to the next slide now. So the next stage is designing our solution. So our oven base design, we need to think about how large our oven base is going to be and how many layers of plastic wrap we're going to use to insulate all of our heat inside our oven. And for our oven flap, we need to decide what angle we want to prop the oven flap at. So the oven flap is going to reflect the sunlight down into our oven base. And so that's why we need to angle it in a certain way that allows us to use as much of the sunlight as possible. And we're going to change that as the day moves on and just sort of experiment with it. We also need to think about how many layers of tinfoil we're going to use to cover the flap. All right. So where do you think the s'mores is going to be placed in our oven? You can type it in the chat. Where is the s'mores going to go? Nathan and Jason say, Ontario Tech Pizza, get your pizza today. That's really funny. So where do we think the s'mores is going to go in our oven? Is it going to be on the flap? We've got on the black paper. Yes, for sure, because that's where the heat's all going to be absorbed, right? Mishi says the base, for sure. Where we see our pizza is right there. That's where our s'mores is going to go. And over top is going to be a layer of plastic wrap. The bottom flap on the black paper or the tinfoil. Yep, on the bottom. Great. So now we can begin to make the model. So I'm just going to play this video over here and pause it at each step so we can build it together. All right. So we need to get our materials all ready. Are you guys able to hear the video?
Yes, you're all good.
Yes.
Perfect. All right, so first we want to have about a 1-inch border drawn around our lid of our pizza box. Okay, so you can use a ruler if you want it to be more accurate, but I'm just gonna use.
Okay.
I'm just gonna do it by eye. Let me just turn off my blur.
Wait, how do we do that? Like, what will it look like? Do we just cut the flaps?
We want to, so you see the lid of my pizza box here? We want to draw about a 1-inch thick border around, and that's where we're going to cut in a little bit. But
Okay.
We're not cutting everything, so don't cut it just yet. Just draw the border.
So it has to be like 1 inch from the edges of the box?
Yeah, just like in this end of the video on the screen here. See that little black outline that they drew? That's about where we should be drawing. If you've got a steady hand, you don't need to use a ruler, but a ruler can definitely help you measure it out. Does not need to be perfect.
I don't know what an inch is.
You don't know what an inch is? I'd say it's about 2 finger widths. So if you can measure with your finger 2 fingers wide is about an inch. Or if you have a centimeter ruler, it's about like 2.5 centimeters. So if you look at my pizza box here, you can see I have a black line that sort of goes around the edges here. All right, everyone drawing their lines. Oh, Nishi, if you don't have a pizza box, you can use any cardboard box, like a shoe box maybe, or any package box that you might have. And if you can't find one, that's okay for now. You can just follow along and watch and see what happens. And all of our sessions are going to be recorded and posted to YouTube, so you can go back and check it later on. And same goes for everyone. If you miss a step or you want to go back and review some things that we've learned or some of the process, you can always check out the YouTube channel where our sessions are posted. All right, are we ready to move on? Not yet, Kareem? Okay, no worries.
Okay.
All right, some of us are ready. We'll just give it a couple more minutes.
Do we need an adult to help us cut around?
Pardon? Oh, we don't need an adult to help us. If you feel more comfortable to have an adult, that would be helpful, of course. But if you're just very careful, you can cut it yourself. Just be very, very careful.
Okay. But I've never cut cardboard in the inside.
Oh, okay. If you haven't cut cardboard before, maybe you want to ask a parent to help you out then. All right. So yeah, if you guys haven't cut cardboard before, just so we're safe and we don't accidentally cut something wrong, you can grab a parent just to help you out.
Okay.
All righty. We almost ready, guys? Got our border. Oh, I see some shaking heads. That is all right. Okay. I'm just gonna start the video now. It's okay if you're not going at the exact same pace as this. The steps are very easy, so we can just quickly watch and see what the next step is. All right, so this person used an X-Acto knife, but you can also use your scissors, and you should only be cutting 3 of these edges that you drew. So
It's not working with the scissors.
not working with the scissors, okay. Maybe you want to ask a parent to help you out then.
Okay.
All right, so you just want to cut 3 of the edges. So you know where the pizza box opens? The side where it's connected to the base, do not cut that side, okay? Because we want our flap to be able to lift up, sort of like, don't know why that happened. So as you can see, he only cut 3 of the sides. Do not cut the side closest to where it's connected to the base, because we want to lift it. So only cut 3 of the sides. It's a little bit tricky, so again, be very careful. Oh, this is tricky. All right. That was a lot of work. All right, yeah. Once you're done cutting your box, just on those 3 edges, just on the 3, don't cut the 4th. Then just comment done or ready in the chat, and that will show you guys what the next step is. You also you can try to sort of indent where that 4th side is, just so we can fold it up on that side. All right, if you're not done, no worries. Just comment done when you're finished. I just made a bit of an indent where that 4th line is, just so it can help me lift it up. All right, so you see we got the lid, we cut it.
Like this.
Oh, it looks like you cut all 4 of the edges. So you only want to cut 3 of the edges. And if you have the top part that you cut off, I want you to tape it on to the side that's closest to the hinge here. It should sort of open up like this. If you can see my camera. So the top part should still be attached on one side, and you can use tape to reattach it just to the one side where it opens up. All right, I'll just give it a couple more seconds. Just comment done once everyone is ready to move on. Mine still smells like pizza. Anyone need a little extra time? Yeah, Alyssa's got some great instructions in the chat. All right, that looks good, Green. Great. Okay, so I think I'm going to start the video again. If you're a little bit behind, do not worry, even a little bit. All right. Okay, so you know that lid flap that we had just now? We want to attach our tinfoil to it. And tinfoil has 2 sides to it. We've got a shiny side and kind of a less shiny, duller, matte side. We want to have our shiny side facing outwards because our lid is going to be reflecting the light into the box. What do you do if you have a box instead of a pizza box? Just make sure that the top part can open and that it's cut out in the same way. So you'll draw that 1-inch line.
I don't get it. Do we have to put the tin-foil inside it or outside it?
It's gonna be on the inside of the lid, right here. See where I'm pointing?
So here.
Yep.
Okay.
I'll cover that with the shiny side of the tinfoil.
Okay.
All right. Be careful with the tinfoil too. The edge of it can be a little bit sharp, so. You have to leave at 10 o'clock. That is perfectly okay. That is when our session is supposed to be ending. And of course, you can always go back to the recording. All right. You don't need to use glue for this step. You can always use tape as well. Just, why don't pizza places just use this style, but electrical and larger? I'm sure some pizza places do, but yeah, I'm not sure why they don't use this style more often. Maybe because it takes a little bit longer and they're used to traditional like pizza ovens. But yeah, that's definitely something to think about. You know, why don't commercial places use renewable energy as much?
This is a good reason to bring back our pros and cons list. We were talking about, if you guys remember, we were talking about how it's really hard to integrate them into homes and just to make farms because they're really expensive to make, right? So maybe that partly may be the reason, but I think it may be a good way, for business to be booming if they use solar energy.
Yeah, exactly. Business will boom. Yeah, they could advertise it as being renewable and maybe more people would like it. But they have to invest a lot of money in it. So, all right. Once you have the tinfoil on the inner edge. Why does it do that? All right, so. What's going on? Okay, so I'm just not going to play the video because it's a little bit messed up. Now you see this like ring layer we have in the middle? We want to cover this ring with plastic wrap. So grab your cling wrap and we're going to be covering that middle layer with plastic wrap. Just grab some tape, make sure it's sealed nice and shut so it insulates it very well.
What do you use tape for again?
You want to use tape to tape down your plastic wrap. So the middle layer, you see this like sort of ring layer in the middle of your pizza box? You want to cover that ring with plastic wrap. Now we're getting near the end of our session soon. So
the top here with tinfoil, and then you just cover all of this with the
plastic, yeah.
Okay.
Where are you supposed to put the plastic wrap if you're using a regular box?
If we use a regular box, so if you cut out that 1-inch border, this middle section, you should still be able to see this middle section where the top part was cut out of. Oh, I see. If you used a regular box like that. So in that case, you might want to cut around the edge so you can lift up that little edge. Does that make sense?
Go around the edge here.
Around like the side of the box so you can lift off that edge, just on the 3 sides again.
Okay.
All right. I'm just going to quickly take this down and explain our last section. And again, if you're a little bit behind,
Not even.
okay, let me quickly take this down. Yes, Nishi, you put it over the square. Sort of like a layer of plastic wrap. So, got my tinfoil, got my plastic wrap, and on the bottom layer now, that's where we want to put our black paper on the bottom, where the pizza would normally go. So we can take down our, bye, for those that have to leave. Thank you for joining. You put the foil around the top. So around our lid here. And if you want to add a little bit of extra foil just to keep it warm, you can add it along the side of the box and the base. So you can sort of see in these pictures, there's some tin foil along the sides, and you can add that later on when you have enough time. But then in the end, we should have something like this. Top layer of tin foil, middle layer of plastic wrap, and then, I don't know, super black paper, but our black paper is in our pizza box. And that's where we're going to put our crayons or our s'mores to test out on a sunny day and see if our solar ovens work. All right, so you can keep working away at that as we move on. So in our last stage, of course, once you've created your solar oven, you can take it outside and put your crayon inside, or put a piece of toast, put a marshmallow in there, and see if it's going to melt or toast itself. And be very careful when you're handling this, because the tin foil and the black paper can all get very hot if you leave it out in the sun. And then, oh, I almost forgot one of the steps. You want to pop it open using your popsicle sticks. So you want to use your popsicle sticks. Once you put your crayons or whatever in your solar oven, you want to use your popsicle sticks, and you want to tape it so that it holds the sides of your tinfoil lid up. And you can test it at different angles during your test and evaluate stage in order to see which angle is going to work the best and make it the most efficient. And this is something that engineers and scientists need to know for energy efficiency, and so that they can maximize the amount of solar energy that they can collect. So just put a popsicle stick on either side of your box to hold it open. And use tape or glue, whatever works for you. Nathan and Jason, yes, then it can have colors if your crayons melt and dry. Yep, your box will be very colorful. Anushka, we don't have time to go back to the video, but just for the tinfoil, you can either cover the lid with glue and then stick your tinfoil on, or you can tape around the edges to get your tinfoil on. Does that make sense?
Yes, and how long does it have to be? Like, how big does it have to be? Like the area of the tinfoil?
You can, if your tinfoil isn't very big, you can cut out multiple pieces as long as the whole lid is covered in tinfoil.
A whole lid, like even the upper part of the lid?
No, just the inside. The outside doesn't need to have it.
And do we have to put it like in the base?
You can put it in the base, sort of as an extra step if you want to, but if you don't have enough tinfoil, it's okay if you don't. You can put it along the sides of the base and underneath the black paper as well.
Okay, thank you.
Yeah, no problem. So during our test and evaluate stage, we want to see if we can successfully toast a crayon or a marshmallow, and then we can think of any changes that we want to make. So maybe we want to add more tinfoil or use a different color of paper or angle it a little bit differently, depending on what works. And we want to keep asking us a bunch of questions in order to loop through our engineering design process and come up with a solar oven that's efficient. And maybe you could open your own solar oven pizza store. It's a good business idea, guys. You can create a hole at the top if you want the sun to come through or smoke to leave. Yeah, absolutely. It's all part of the test and evaluate stage to see what you want and come up with more ideas. And that brings us to the end of our session. So if you have any questions, you can leave it in the chat. And I hope you had a lot of fun learning about solar energy with us and creating our own solar oven that we can test out outside. It's pretty sunny out today, at least where I live. So later on in the day, maybe around noon, you can test out your ovens. That'll be a lot of fun. So thank you everyone for joining. We're going to be logging off soon. And if you have any last minute questions, you can just leave it in the chat. The plastic wrap goes on this middle layer. So where we cut out the top, it's going to cover it sort of like a window. No problem, Nathan and Jason. Thanks for coming.
Okay, but so we put it like we cover the inside of this like flap thingy.